So good afternoon. I'm Dan Knutsen, the acting cFS PDL, and I'm going to be discussing cFS, what we've recently accomplished, where we're at, and where we intend to go. So even though most of you here know cFS, I'm going to walk through a quick overview for those of you that are new. So cFS is a generic embedded systems framework used on a variety of projects, from telescopes and rovers to CubeSats and drones. Similar to Android and iOS, cFS creates an open platform for sharing, collaboration, innovation, and commercialization. And we're essentially using cFS to create an app store for space. So this is the classical chart shown dozens of times. We have the CFE in the middle, which supports the execution of apps and libraries. Underneath that, we have the OS abstraction layer and platform support package, which abstracts the OS and platform-specific functionality. So cFS is a platform and project-independent reusable software framework and a set of reusable software applications. Abstraction supports portability, applications provide mission functionality, and compile time parameters and runtime command and table parameters add flexibility and scalability. Some of the key aspects are it's a dynamic runtime environment. Applications can be added and removed at runtime. It has a layered architecture with the abstraction layer at the bottom, the CFE core in the middle, and the software applications on top, which add the mission-specific functionality. Also, it's a component-based design, which means it's built up of manageable and, most importantly, reusable parts. And also, we provide consistent APIs. Slide 4 is our goals and objectives. So we want to provide a reusable framework that will allow projects to reduce cost and schedule to deploy high-quality flight software. We want to enable collaboration across projects, centers, and agencies, facilitate software reuse, simplify sustaining engineering, and streamline development and ground tools. We will never make spacecraft flight software easy, but we can try to make it less hard and continue to reduce the cost to access space by advancing cFS and continually making it a better product, by adding to the App Store and providing projects with increasing out-of-the-box functionality so that we can continue to support more projects better. And in doing so, better understand this Earth and the universe that surrounds us. And when all that's said and done, challenge the next generation to do it better. So I really like this chart. It's CFS used across NASA centers. And I mean, it's really easy to see the impact CFS has had. At a minimum, we're used at 6 centers and by over 40 projects. It's an amazing accomplishment and speaks volumes to the success of the people that started it. Since I've been on the team, which is a little over 3 years now, we've never been more than 3 or so total people. And we try, not always successfully, to cater and support as many projects as possible. And we've managed to be at least partially successful because of the forward thinking of our predecessors. So shout out to them. Thank you and congratulations to those that are listening. Look at the chart. It's an incredible accomplishment. So going through our recent accomplishments, we released Draco RC4 in February of this year. With the Draco development cycle, we started to release each release candidate with all of the artifacts associated with the complete build, including updated VDDs, user's guides, unit and functional test results, requirement documentation, build verification test results, and design documentation. Some of the noteworthy accomplishments include significant unit functional and build verification test updates. We cleaned up hundreds of static analysis issues. We reached 100% masked MCDC coverage on our 10 open source GSFC apps. We went through a significant refactor of CFTP and a significant refactor of the Doxygen generated user's guides. We closed 506 issues, 514 pull requests, and 69 bugs. We also submitted NTRs for the Draco development cycle, scheduler, and file commander, all of which are planned to be open source released under an Apache license. In addition to that, Jake Hegman alone had over 3,000 contributions to the open source community. combined with Joe Hickey's X number of thousand, I'd say it's been a pretty good run. And I want to give credit where credit is due and recognize that we would not be where we are today and would not have had such a successful development cycle specifically without the contributions of those two. So for those of you that are unaware, we are on GitHub. This is a snapshot of our main page, as well as a link to our the repo. So in addition to providing the software itself, these are our build release artifacts. Shown here is Draco RC4. So this is where you can link to the BDD, users guides, unit test results, unit test coverage summary, unit test coverage details, build verification test results, design documentation, and requirement documentation. These are the 10 open source apps that we released as part of our build release. We have data storage, file manager, housekeeping, health and safety, memory dwell, checksum, limit checker, memory manager, store command, and CFTP. This is another snap of the main page that shows the additional open source tools and resources. We have 16 open source apps, 10 of which are currently maintained. Those are the ones that I discussed on the previous chart and are tagged as part of our build release. And essentially, this is our attempt at creating the app store for space that I referenced earlier. The focus of today's discussion is EDS and CTF. So that's electronic data sheets and a cFS test framework, which is a lightweight ground system built and maintained by JSC for the purpose of flight software requirements verification. So both these topics have been discussed at previous workshops. And I'm going to talk about how we plan to use these tools to reduce the overhead of deploying cFS. So EDS is used to define message exchange formats for all software components. It defines binary formats of messages on the wire and can define interfaces at multiple communication stake layers. And both EDS and cFS are required by NASA's International Deep Space Interoperability Standards being used on the Artemis program. So I'll get into it in a bit more detail in a few slides, but at a minimum, what we plan to do in the next development cycle is use EDS to define command and telem definitions for CFE and the 10 open source apps, which will essentially act as an ICD for projects using cFS for command and telem definitions and ground tooling. So why use EDS as the definition? Well, it's simple. It's forward thinking, and there's plenty of room to grow once we've established that. And that's essentially what this chart communicates. The use cases include page displays, ops procedures, test procedures, simulators, models, and various generic software components. This is basically a continuation of the last slide and shows EDS use cases for hardware as well, including star trackers, thrusters, and sun sensors. So slide 16 shows some of the inefficiencies in our current process. The main one being that for each release, users use the BDDs and users guides. BDDs and GitHub issues and pull requests to identify changes needed to be made for a given project's database and ground tools. So shown here is the CFE BDD, as well as a snap as the CFE closed pull request. Often, changes are missed during the evaluation process and ultimately result in test failures during flight software verification and integration and testing. Fixes are then required to upgrade command and telem databases and ground system tooling. The later issues are identified, the longer it tends to turn around updates because of the natural increase in configuration management needed as projects get closer to launch. And this overhead exists for every project that uses cFS. So what we'd like to do with Aquilus is release formal command and telem and load dump file table definition files using electronic data sheets for CFE and our 10 open source apps. This will provide a single source of truth for projects using cFS and will minimize the overhead required to configure and maintain a project database and ground system tooling. We will also be providing a mechanism to convert the EDS files to the JSON format needed to functionally verify EDS definitions via the cFS test framework. We also plan to open source release the CTF test scripts necessary for project independent verification. So it's a pretty simple process, but slide 9, so this slide basically visualizes what this is going to look like. We're going to start by manually building and manipulating the EDS files, which are essentially XML files. We're then going to convert them to JSON, the JSON format, which can be ingested by the CTF, the cFS test framework. We're then going to functionally verify that database via CTF testing. And then we're going to rinse and repeat that cycle until all the tests pass and we have a solid set of EDS files. So this is a snapshot of the test results overview that we released with Draco RC4. So we essentially did this for Draco RC4, but we did so using Gateway CCDD database and versions of CITO and Scheduler. So that was a good run. And the one challenge for Aquilus will be integrating the build verification testing using the EDS generated database and versions of CI Lab, TO Lab, and Scheduler Lab. So once the EDS definition files are defined and vetted, numerous future enhancements are possible, the top two being Lua and Python scripting engines, and using EDS to send commands and receive telem from onboard scripts, which, if deployed correctly, has the potential to allow for simple and powerful replacements to stored command and limit checker. It could eventually lead to us rethinking how we handle fault management and spacecraft operations in general. Any questions? Yeah, I kind of rushed through that. It's a little faster than I thought.
All right, and we'll start with a question over here.
Dan, thanks again for coming to talk. For folks who don't know, EDS